1. This is lecture number 16 and the topic is threaded fasteners. Now, we are discussing different kinds of fasteners, and fasteners are non-permanent type joints where the members could be disassembled according to our will and without damaging the component parts. So, threaded fasteners are one of the very important kinds of fasteners where, of course, as the name suggests, there are threaded members. In today's machines, most of the machines will have different kinds of threaded fasteners. Normally, a rough estimate is that about 60% of the machine elements are now threaded, have threads. So, and the fasteners types are threaded fasteners. So, we are going to discuss different kinds of threaded fasteners in today's lecture. First of all, let us see what are the different types of threaded fasteners. Now, the first name which comes is the bolts with nuts. Now, this is a very common type of threaded fasteners which all of us are acquainted with. Let me draw a rough diagram of the this kind of threaded fasteners where through bolts with nuts. Now, the purpose is to join two members. Let me denote this two members as two plates. Let us say one plate is here and the other plate, let me take the other plate to be this one. So, this is a part of the plate and this is another plate. Through bolt with nuts, what we do here, we first drill a hole through the two parts. So, first of all, we drill a hole and then insert a bolt. So, now a bolt is inserted. There is a headed part. There is a head, and here we have the threaded parts. And then we place another thing which is known as nut here. So, this is nut and then tighten them. So, this is what is known as through bolts with nuts. Now, this part is known as the bolt. Now, if I draw the cross section of a bolt, then it looks like here this is the head of the bolt which has different kinds of cross sections. It may be hexagonal, it may be square, and this is the main body of this bolt, it is a cylindrical body, and there are threaded parts over here. So, this part there are threads and you see there is a sharp change. So, that is not allowed normally in any machine component because of stress concentrations. So, we have a radius. So, this is the fillet radius, normally a radius is given. So, this part is known as the head. This is the main body which is known as the shank, and this is the thread. This is what is known as the bolt. Similarly, we have a nut which has internal threads. Now, it looks like the head of the bolt, but it has internal threads. So, these are the diagrams of bolts and nuts. Now, next is the bolts with tap holes. Here we have bolts with tap holes. Now, the arrangement is again we have to join two plates. Let us say one is little thicker than the other. So, this is one plate, the other is this one, and then what we do, we first draw a hole there. So it's not a through hole, but what is known as a tap hole, and then this part is made a hole, and here this is tapped part, and it has screws here. And then what we do, we insert what is known as this bolt again. So this is a tap bolt. So this we insert this one. So this is inserted, and now this is a secure joint. So this is bolts with tap hole. Now there is no need of, so there is no nut, but one of the disadvantages of this kind of arrangement is that whenever we want to open it, that is, we give a opening torque, that is twisting torque, and then it damages the thread. So that is to be prevented, and for that purpose we sometimes use the stud. Now what is stud? Stud is very much like bolts with tap holes, but it is we use the nut over here. How does it look like? Let me explain. Again, here we have two plates. We again drill a hole. This has again part. Now we introduce here what is the stud, and stud has screw, the threaded parts in both sides. So now we have a stud, and then we tighten it by means of a nut. So this is, let me draw a different color. So there is a nut over here. So this is the stud. Now this is used again in various elements, machine elements. The advantage is that the threads are not damaged as it occurs for the bolts with tap holes. Now there is another kind of threaded fasteners which is known as cap screws. Now cap screws are just like bolts with tap holes, but it has various kinds of head shapes. So let me draw a few. So cap screws, it will have again so now threaded parts and head. Now there are different kinds of head. So one kind of head is hexagonal head. Where this is the head shape, and this is the cross section of this head. So this is hexagonal. Then sometimes we have head of different kind. Head may be something like this, where the cross section looks like let's say slot cut over here. Then there may be round head. So this is another kind. So there may be round heads where it looks like, and there is a cut over here. So now the cross section This is another kind of head. The other kinds, let me draw one. So now it has again this part, but this looks like here, then there is a hexagon slotted over here. Sometimes the head shape also looks so this is a fluted arrangement, and this is hexagonal socket type arrangement. And also there is another kind of cap screw which has a head of this shape. So this is another kind of cap screw. So these are roughly different kinds of cap screws. Now machine screws, now we come to machine screws. Machine screws are something very much similar to cap screws, but it has slots on the head which provides the insertions of screwdrivers. Set screw are very important screw members where which are used normally to connect two rotating members. Now as we have discussed in connection with keys and couplings, the two rotating parts, two shafts are normally coupled by means of a coupling or keys. Sometimes machine set screws are also used to prevent some kind of motions. For example, when we use the feather type of key, then the axial movement is not prevented, but if you want to prevent the axial movement, then we fix these two members additionally by a set screw. So that arrests the motions along the axial directions. So set screws, which is very much like the cap screw, but it has important difference in the threaded part, that is the head may sometimes look like this, square headed, but here this is threaded part, and then this one here, this has various, so this profile, this part of this this member will have various angular. So this is angle maybe 90 degree, sometimes it is totally conical, and so on. Again this angle maybe 90 degree. So all kinds of shapes are there. Now what is the purpose of that? That is very easily seen if you draw two shafts which are connected together. So let us consider one shaft and maybe another disc. And we insert set screw over here. Now you see a groove will be cut over on this shaft, and this part, that is this end part of this set screw, will have adequate friction to arrest any movement. So this part, so the entire connection is through the friction. Therefore as expected, the load carried by this member will be relatively small. So the set screws are used to connect two shafts when the load is relatively small. There is another kind of screw which is known as foundation bolts. Now that is important when you have a large machine structures which is to be connected to, which is to be fixed on the ground, and we have to arrest the motions of the that is the vibrations of the structure. So, therefore, the foundation bolts are required. Example, let us consider a very tall chimney, maybe a tower. So, here we will have various bolt connections. Now, these bolts are foundation bolts. The foundation bolts are of various shapes. One such I am drawing, but there are other kinds which look quite complicated. Foundation bolt, sometimes one is just like this part is added, so that extra strength is provided. Now, these are different kinds of the threaded fasteners. Now, we come to different types of locking devices. Now, what is locking device? We know that all the machines will have a tendency to vibrate. So, there are always some sources of vibrations which will eventually vibrate all the members. Now, the joints are very important in sustaining these vibrations. That is, when the two members vibrate, then the joints also vibrate, and because of this vibration the screw may come out. See, the process of the self loosening of the screws are very complicated, but what is important is that the screw will eventually loosen and will come out. So, therefore, the strength of the joint gets weakened. In order to overcome that is, in order to resist the vibrations, prevent the vibrations, we have different kinds of locking devices. Now, the first kind is known as the jam or lock nut. Here, let me consider one bolt. So, two members connected by means of through bolts. So, here is a bolt and now there on the top we have nut. Now, instead of having one nut which will try to loosen, we use two nuts. That is, we first remove this nut, put a small nut, that is a thin nut, one thin, very thin nut, and then tighten it normally. Then on top of it we put another nut. So, there are two nuts which are put one above the other. We tighten the top nut with very high torque, large torque, and then loosen this bottom nut. So, eventually all the load will be taken by this thick nut. And what is the purpose of that? That arrests the vibration. So, when it tries to come out, then this nut provides adequate friction, so that the nut does not come out and the bolt does not get loosened. So, this is known as the jam or lock nut. Sometimes we use two nuts. Now, here we have we use two nuts together, and the thickness of the top nut, that is this one, is normally larger, but sometimes we use the bottom nut to be of larger dimension, which is not very effective, because the most of the load, as I said, will be taken by the top nut, and therefore we use this two nuts of the same thickness. So, the thickness of these two nuts are almost equal. So, if this is T, then this is also T. So, these are used sometimes and they are known as lock nut or jam nut. The next type is known as castle nut. What is castle nut? Now, here this is normal kind of nut. So, this is a nut, and on the top of it we have a cylindrical surface. So, a surface is made cylindrical, and at each of the center of this faces, if you see, it will have, see from the top, so at each of the center here we cut a slot. So, these are slots cut, and whenever we insert a bolt, let us say this is the part of the bolt, then by means of split pin these two are connected. Now, we put we drill few holes on the bolt and then insert the split pin, and we make a positive connections, that is, now it is secured against any movement. So, therefore, the vibration will not affect that. This is a castle nut. It is very commonly used in many automobiles. The next kind is known as the sawn nut. What is that? Sawn nuts are again like a nut, where this part temporarily there is one slot is made, that is near half of this a deep slot is cut, that is by means of a saw, and then we provide another set screw over here. So, there is another set screw inserted. So, this is the set screw. Now, what is the advantage here? Whenever this is the bolt. So, whenever it vibrates, so the set screw, it provides additional frictions, and that gives the required damping to resist vibrations. So, this is known as sawn nut. Then pen, ring or grooved nut, this is the next kind. Pen, ring or grooved nut. Here the structure is not complicated, but it looks like there is the normal nut, and then a cylindrical surface is cut. Here by, so this is the surface and the bolts are here, and there is a cylindrical surface where a recess is made. Now, through this recess a set screw here is put. So, there is another member, and here a set screw is kept. So, this provides again some damping, and this kind of nut, that is pen, ring or grooved nuts, are normally used whenever we joint, we provide this this arrangement near the edge of a plate. That is, whenever an edge is nearby, then we use this kind of nut, grooved nut arrangement to prevent the vibrations, that is the self loosening of the bolt. Then locking with pin. Sometimes we have So, we give two pins, that is a slot is cut, that is a drill is made and a taper pin is inserted. So, this is the taper pin is inserted. Now, we have already discussed the how to design the pin joints. Now, this is the same kind of tapered pin used to connect nut and the bolt. That is, we give some arrangement here the pin, so that there is no relative movement between the nut and the bolt. So, this is locking with pin. The last kind is known as the washer, which has very intricate shapes, but normally we are all acquainted with this kinds of different kinds of washers. Now, washers are made of leather or sometimes some metallic parts, but there are various kinds of washers available. There is another a very interesting kind, which is the spherical washer, which provides for the misalignment of the bolt. Now, when we discuss about the design of the bolted joints, then we shall discuss that if there is a misalignment between two surfaces which are to be joined, then a bending stress will develop. Now, in order to alleviate this bending stress, sometimes the spherical washers are used. So, that provides the required flexibility against misalignment. So, these are the different kinds of locking devices. These are very important, because otherwise the machine will vibrate and the nuts and the assembly will loosen, that is nut bolt assembly will loosen on its own. So, these are to be prevented, and those are prevented by various techniques as discussed here. Then we have talked of different kind of fasteners, and I have already told that they are used in great number in a modern machinery. What are the advantages of threaded fasteners? Let me look at them. The first advantage is that ease in assembling and disassembling, which is very important, because we have to assemble and disassemble these different components because of the maintenance purpose. And if the joints are permanent, then they cannot be assembled, disassembled. If the joints are non-permanent, then they are to be assembled or disassembled with ease. So, this is actually provided by the threaded fasteners, because you see that they can be conveniently used, conveniently assembled or disassembled, and the maintenance becomes easy. Then the second point is that the reliability because of the self-locking effects. Now, while discussing the power screw, we will have chance to discuss about the self-locking effects. Let me explain briefly. Self-locking effects are those effects, that is, whenever there is a load applied, then if the load is removed, the threaded fastener should not come out of its own. So, this is very important, because that gives us some reliability measure. That is, we do not want to keep an eye on the threaded fasteners all the time. We fix it up and then may forget about that. It will not come out on its own. So, this is the self-locking effects, and for the threaded members, this self-locking effect is very important. So, here we have one advantage, that is reliability because of the self-locking effects. Then the manufacturability, that is very important factor for design, as you have already learned that the manufacturing is very important thing. So, the threaded fasteners are manufactured in a great lot, in a large amount, very standard way. So, there are various standard techniques for manufacturing threaded fasteners. They may be turned, there may be machine operations or hand operations, screw tap operations. The threaded members may be rolled also. So, there are various techniques, and they are so standard that the manufacturing cost of a threaded fasteners is very small. So, this is one of the very good advantage of the threaded fasteners. Now, what are the disadvantages? Disadvantages are that large stress concentration is developed. Now you see, when I have drawn the threaded fasteners, then here this is the bolt, here there is screw, so thread members. So there is a large an abrupt change in geometry over here. So there are abrupt change in geometry over here, as well as the threaded members. If you look carefully, then the threaded members, so there is a change in geometry here, there. So there will be lots of stress concentrations, and that is very very dangerous, because the large stress will be developed and that may lead to failure. So lots of time it has been found out the failure may take place here or in the thread. The threads will normally take all the threads will not take the same load. The first thread usually takes the largest portion of the load. So therefore the failure may take place near the first thread. So there are different kinds of failure techniques, failure modes for the threaded fasteners, but they all occur because of the large stress concentrations in various components, in various parts of the member. The second disadvantage is that wear and tear may take place. So this is very important, because due to wear and tear the material may get lost, and that eventually leads to the weakening of the this member. So the strength may be reduced because the material is removed. So therefore it may lead to failure. Also wear and tear, for this the material loss is material gets lost, and therefore this is a loss in terms of money. So these are different disadvantages of the threaded fasteners. Now we know what are the advantages and what are the disadvantages of a threaded fastener. The next we see, we have to study the design of threaded fasteners, but what is most important in a threaded fastener is the thread. So we have to now study the different geometric properties of the of a thread profile. So first let me draw one thread profile here. If we have one bolt, and we make a cut across along the axis, so then we get the cross sections. Now what I am doing is the cross section of this part, and so here is the cross section of that part, the threaded part. Now what we see, so this is cylindrical part and cylindrical part. Now if we draw one coaxial cylinder such that its surface touches the outermost points. So this is the cylinder whose surface touches the outermost point. So this diameter is the measured diameter. Now the measured diameters are sometimes called the diameter or the nominal diameter of the bolt or the screw. Similarly, we can have another cylinder, imaginary cylinder, which passes through the lowest points of this threaded profile. So this diameter is known as the minor diameter, and there exists one cylindrical one cylinder which may pass through this point So, this is again a cylinder. What is the property of this cylinder? What is the speciality? That is this point, so that is this part which is the portion cut by the space between two threads, and that part, that is the part of the cylinder, that is the distance, axial distance between 2 points of the thread along this surface, these two are equal. So, these two are equal. So, this is x, that is also x. So, this is the special property of this surface, and this is known as pitch diameter, that is diameter of this is the pitch diameter. This is very important from design concept, because lots of properties will depend upon the pitch diameter, and this is sometimes also known as the effective diameter of the screw. Now, what is a pitch? Pitch is the distance, axial distance between two points of the threads, which two similar points on the thread. That is, let me explain with the help of another diagram. Here so So, this is the threaded profile. And this distance, that is, this is the pitch, which is, that is the distance between two consecutive threads and along the axial directions. Then lead is very important. This is the distance by which the screw travels if it is rotated by one complete revolutions. For a single threaded screw, then the pitch is equal to the lead, but for a multiple threaded screw, then the pitch, the lead is equal to K times P. That is, P is the distance between two threads, but for one revolutions it advances by one L, that is one lead, and that is equal to K times P, which is K is equal to the number of threads. That is, if it is double threaded screw, then lead is equal to twice that of pitch. If it is triple threaded screw, then this is 3 times P. So, this is so on and so forth. So, these are the different geometrical properties of the threaded profile. Now, what you see here is that threads are the thread profiles are part of a triangle. Let me draw. Threads so this height is the height of this triangle, but sometimes not full threads is used. So, there may be a cut over here. So, the threaded profile may look something like this. So, a clearance is given. So, there is a clearance H, maybe H1 and H2, etc., etc. So, this is very important while designating the thread profile. We are going to study some of them very soon. So, now you should be able to tell what are the properties, what are the definitions of different geometrical parameters, that is major diameter, minor diameter, pitch and lead of a screw. Then we study some of the normally used thread profiles. So, what I draw here is the cross section of the thread. The first is the British standard Whitworth threads. Now, it has the profile like a V, but now here you see this is a part of a triangle, but some clearance is provided. This angle is 55°. Now, this has a large root strength, and but this has some coarse series, so it's not a fine pitch. All the dimensions can be found out in machine design handbook, but I am not drawing it here. But what is important is that the root strength of this kind of thread is quite high. The root strength is very important because you see this, the thread arrangements, if this is thread, then the force may be applied over here. You see, whenever the nut is engaged, the force will be applied. Now, ultimately all these small triangles, they act like a cantilever, and the large stress may be developed near the root. So, if the area of cross section of this part is large, then of course the root strength is quite large. What are the uses of this British Whitworth threads? The uses are mainly special purpose or adjustment screws or aero and automobile parts. So, they are very oftenly used threads. The next type is the British Association thread. Now, this is used, again it has the profile something like this. This angle is 47.5°, and of course, all the other dimensions could be found out, but there is a large radius over here. Now, this radius is these radii are provided so that the stress concentration becomes low. Now, this part, this kind of threaded fasteners, this kind of threads are used for precision works. Now, this is about the British Association threads known as the BA threads. Then the American National Standard threads, here the thread profile is like a V, something like this. This angle is 60°, and all the other dimensions, that is clearance, etc., these are given in the handbook, but this is normally used in very common applications. This is known as the American National Standard thread. The Unified Standard thread in 1948, Great Britain, America and Canada, they came to one unified standard. And what is that standard? The profile looks somewhat like they take the two advantages, the different advantages of two types of threads, that is American National Standard threads and BSW threads. So, here this is the geometry is, again it is rounded over here. This angle is 60°. It has, but this is now rounded, and these dimensions are again given, that is the difference between the apex of this vertex of this triangle and this part, that is the clearances, or yes, you can talk of the clearance. Then these are all tabulated in the design handbook. So, these are unified standard threads. Then the next type is square thread. Now, the square threads, they are used in various machine parts. The square threads, as the name suggests, the profile is square. Here again this is square, and this distance, this is the total P, and this distance is P by 2 and P by 2, and this distance is also P by 2. The advantage of this kind of threaded profile is that it has a high efficiency. We see when we study the power screws, then we see that the advantage or the efficiency of the screw to transmit motion, transmit power from one member to the other depends on this slope. Now, if it is 90-degree slope, that is this angle is 90-degree, then the efficiency is the highest. So, this is very often used in power screws to transmit motion in both the directions. So, normal uses are the feed mechanisms in machine tools, valves and spindles, and then screw jacks. We will have enough opportunities to study in details about this kind of screw threads in due course. So, this is about the square thread. Then comes the acme thread. Now, the square threads have the advantage that the efficiency is more, that is the frictional loss is less, but it has the disadvantage that the root strength is very low. As you have seen, half of the roots are the load is taken by P by 2 only, that is the distance is P by 2, the other half is empty. So, therefore, the load carrying capacity of a square thread is quite small. Now, in order to overcome that, we have another kind of thread which is known as acme thread. Here the thread profile is like P, so this is the profile of acme thread, and this angle is 29-degree. Sometimes we have 30-degree, which is trapezoidal thread, but it has the advantage that a large root strength is developed, and also whenever we have the occasions to have frequent engagement and disengagement of nut. Now, nuts may be sometimes disengaged and engaged frequently. So, whenever we have that occasions, then this kind of thread, that is which a V groove, it gives us some advantages. So, in lathe machine, for example, we have this kind of requirement, that is the nuts, the lock nuts are to be arranged to be engaged and disengaged quite frequently, and we have acme thread there. So, different uses of the acme threads are screw cutting lathe, brass valves and bench vices. We again have some opportunity to learn about acme threads, different properties of acme, that is the advantages, dynamic advantages of this acme threads in somewhat great details later on. Then the knuckle thread, it has the profile here again, this is P and P. Now, this has the advantage that it can be made very easily by rolling or casting, but the disadvantage that the machining cannot be done so effectively. So, the surface finish is not that good, therefore, it cannot be used for any precision operations. The normal uses are railway carriage coupling, necks of glass bottles, which you have already seen. The glass bottle looks like, the threads in the glass bottle looks like somewhat very curly here. So, this is knuckle thread, and then large molded insulators in electrical machineries or electrical appliances. Then there is buttress thread. Buttress thread, it looks like here one part is quite stiff and the other part is relatively slopy. So, on this slope is 45 degree and this slope is almost 7 degree. So, it has advantage that it is used to transmit power from one direction only, and it has advantage that whenever this part comes in contact, so the friction over here on this surface is small, whereas it has a large root strength because the large cross sectional area at the root. So, this is known as the buttress thread. Then we have the metric thread, which is the IS thread normally, and this is almost similar to BSW thread. So, this looks somewhat like the nuts, they come over here, so on. So, these are the nuts and this is the thread. So, these are used in Indian standard. Now, these are different kinds of normally used threads. Now, the designation of screw threads, now these are done in the Indian standard, namely IS 4218 part 4, and this was affirmed in 1978. There are two kinds of designations, one is size designations, and this is done by a letter M for metric thread, and then comes the nominal diameter, the D major or the nominal diameter. Then it is followed by a cross and then the pitch. If pitch is not there, sometimes pitch, this information is not there. So, it is to be taken that this belongs to a coarse series. So, in fine series there are two kinds of series, one is coarse series and fine series. For coarse series this P is not there. Then the tolerance designations, the tolerance grades are there. Then the tolerance grades may be for different. For fine grades a symbol on number 7 is used. For 8 this is normal or medium grade, for 9 this is coarse grade, and tolerance positions for H unit thread, for D this is bolt thread with tolerance, and H bolt threads without tolerance. I shall give you one example. If you are asked to find out what is the properties, let us say M6 8D, that means M is the metric threads, 6 is the nominal diameter of the screw, that is the major diameter is 6 millimeter, and there is no cross and P. So, therefore, this is taken to be a coarse series. Then 8 stands for the normal or the medium grade, and the tolerance has to be given in the bolt threads. So, this is the metric threads of 6 millimeter nominal diameter, and the this is a medium graded threads where the bolt threads have tolerance, medium tolerance. So, these are roughly the designations of a screw threads. Now, let us come to the end of this conclusions of this lecture. We have studied different kinds of threads. Threads are very, very important because of different advantages which we have seen. It is easy to disassemble, assemble, the manufacturing ease is there, as well as the reliability is very much. So, but the disadvantages is that the stress concentration is there, as well as wear and tear may take place. But in spite of that, a number of machine parts are joined by threaded fasteners. So, in the next lecture we are going to study how to design such a threaded fasteners. So, for this lecture this will be sufficient, I guess, and that is end of that. So, thank you very much. Dear students, let us begin lectures on machine design part 1. This is lecture number 17 and the topic is design of threaded fasteners. Now, in the last lecture, that is on lecture number 16, we have learned different geometrical profiles of different kinds of threads. And now threaded fasteners, as we have discussed, they are very useful, and in many machine parts the parts are joined together by means of threaded fasteners. So, design is very important for this kind of machine elements. In this lecture we are going to learn how to design such a threaded fastener. Now, let us come to the design. Now, the design will depend on definitely on the material selected for the fasteners. So, these are what you are seeing is a list of the screw materials. Now, the screw materials will be chosen depending on the application temperature of the applications. Now, the room temperature applications, the materials are low carbon steel, this is for the light structure, and maybe medium carbon steel, but it must be heat treated. There are various processes of heat treatment, and these are all specified in standards. So, when you have to design such a threaded fastener, so you will have to look into the standard. There are different material standard, and the medium carbon steel with different kinds of heat treatments are possible. Quenching and tempering, these are the two most useful, that is most frequently used heat treatment process. For the high temperature, the alloys are used. Now, titanium based alloys are used for high temperature. Then as the temperature goes high, then we use martensitic chromium steel, here the chromium is added. Then inconel, for a very high temperature, inconel and super alloys are to be used. So, this information is very much essential.